quite a few things. The new Vibrio challenges, of course, but also new knowledge of microbiology, improved probiotics, and better food, better tools to analyze. Now, when we look at the Vibrio challenges, we've been talking about the different diseases that have been affecting shrimp farming, and EMS has obviously been a major issue, starting from Asia and then spreading throughout the world. Now, if we look at Vibrio and EMS specifically, this is caused by, you heard many times, one species of Vibrio, Parahemolyticus, but more specifically, there's a timer, I don't know, more specifically is some plasmid. And why is it so important? Because as was presented earlier, you increase the risk, of course, of transferring the genes associated with the production of the toxin. So this has been documented. The risk was well discussed when the disease started. And the danger means that instead of focusing on one species, we analyze the pathogen, we know we have it, we are safe. It's not the case anymore. We have to consider all the Vibrio in general. And from the theory, we went to the reality. And you start to see now many papers coming out to explain the presence of these EMS-type Vibrio. And it means many different species of Vibrio, not only Parahemolyticus, but you have a whole range. It was presented also the situation in Ecuador. So this is really something that we are seeing worldwide. So the first point from this is, because of EMS, it's not only one species of Vibrio, but we have to start again to consider all the Vibrio species. The next step, it's about communication between Vibrio. So we hear about quorum sensing, which is basically the mechanism used by bacteria to communicate. All bacteria do. And when we look at this, it's simple. It's just a signal molecule from one bacteria to another of the same species. And once there's sufficient communication received, the right number, what we call the quorum, well, some genes are activated, in this case, toxin production, and the disease may occur, you have the release of the toxin. But when we looked at it, the first point was, are Vibrio like Babel Tower? Meaning each species of Vibrio would have its own language. Meaning the molecule that is used by Vibrio havei is only valid for Vibrio havei. Another species would use a different one. If it's that, you can assume that you only want to focus on controlling the one species of Vibrio that you know give you the disease, the problem. But it's not the case. When we look at the nice review that was done by scientists from University of Ghent, they looked at all the molecules, signals, that are used by different species of Vibrio. You see a lot of different signal molecules, so not only one, many. But what you also see is one of them is present throughout so many species, meaning that it's possible that the pathogen, I go back to the one I showed you earlier, these two, yellow, let's say they are the Parahemolyticus, they communicate, and then we have two other species of Vibrio, different color, and the question is that maybe now another species of Vibrio, which is not virulent, still give the signal that is collected by the virulent one. So the consequence is that it's not so simple. You have to start to consider that all the different Vibrio may communicate among one another and may affect the activity of the pathogenic one. So it brings more complexity. We don't necessarily have answers, but it could be an example. If you remember, in Thailand a few years ago, there were stories about white feces outbreak and how the white feces might be caused to HPND, EMS, Vibrio, at a low virulence or low concentrations. it could be that they are present in low numbers. So if they produce toxin, they may not have sufficient production of toxin to kill, but sufficient to affect the health of the shrimp, hence the white feces. So there are many points that we need now to consider. Another thing, of course, is the interaction between the different pathogens. Now, we had first EMS, HPND, then EHP, and now we have others coming in. But this is a nice work where they looked at interaction between AHPND at low concentration, AHPND at low concentration together with EHP, or then HPND at high concentration. And you can see the mortality. If you have low concentration of HPND, you have mortality of 0 of 18%. But when you combine the same Vibrio together with the HP, you have then a real mortality coming in. So it's never simple. The same, there was the work on the communication, the synergy between white spot and Vibrio, where you know that if you have Vibrio, a white spot hitting a shrimp, there's enough evidence that the shrimp is weaker and cannot fight a standard Vibrio attack. So it is then killed by the Vibrio because it's not able to clear its hemolymph. This shows you similar, but this time with the HP. So there are many more things to consider. It's not one pathogen alone, but it's how all the pathogens can interact. The next step is, we heard before, antibiotics don't work. Antibiotics don't work to control biofilm, and many Vibrio make biofilm, so this will not help for that. But also, you see when EMS came, whether it is in Mexico or in Vietnam, the typical reaction was, let's try OTC, Oxy, and other antibiotic, one after the other. And what we've seen, whether it is in Mexico or in Vietnam, the same. We start to see the appearance of these OTC-resistant Vibrio strains and other antibiotics. So it was clear that relying on antibiotics was never going to be the solution for this disease. Well, once we look at that, we have to see why did the traditional shrimp farming fail. And for this, now we understand more how the pathogen, in this case for EMS, the original Vibrio parahemolyticus, now we understand it's not only that, we have to look at overall the Vibrio. So now the question was to try to understand why did we face this problem in the shrimp farming. And for this, we maybe live too long in Asia, so we need to make manga a little thing all the time, but so you will see. It's representing all the bacteria in a shrimp pond. And you may describe basically 3 categories. You will have those that are neutral or beneficial, those that are clearly pathogenic, and a vast number who are just opportunists. They may give you problem sometimes under specific condition. Now, what do we want, obviously, is only keep the good one, avoid the pathogenic or the opportunistic one. And how have we done this? Well, disinfection, standard protocol. So what does it mean? You kill everything, and then you have an environment which is empty of bacteria, but with nutrients present. And because of that, bacteria that are present in small number will start to recolonize. And this is where you have to consider 2 types of bacteria, not species, but bacteria based on their ecological behavior. What we call the R strategist, and the others the K. And this is based on the ability of these 2 bacteria to utilize nutrients and to grow faster or not, and therefore to become dominant or not, according to the situation. We can summarize very roughly these. And if you look at the R strategist, very often these are the potentially the opportunistic or the pathogenic Vibrio. HPND1 is typical. The K typically are the neutral or positive one. Now, what it means is when you have a lot of nutrients, these are the R strategists that will start to bloom and dominate the system. And what it means is when you have an unstable system after algal crash or rainy season, when you have disturbance, and which one will react to the change and become dominant, these are going to be, again, the R strategists. So we need to find a way of controlling these in order to give an advantage to the K, the good one. And when we look after disinfection, we're going to get a few remaining, but we have a lot of nutrients and open space. So the one that will become dominant will be the fastest growing one, typically the bad one. And they will become very dominant very fast. The good bacteria that we presented earlier, the slower one, they will grow, but much slower. And that means that very early in the management of your pond water, you will end up in this situation where you stock your shrimp, and this is where you have mostly the opportunistic or the pathogenic one present. So when EMS came in Asia, people looked at two approaches. One of them was, let's remove all the waste. No nutrients, should be easier. And this is the shrimp toilet approach, or whatever you want to call it. But central drain, take everything out. And another way has been try to exchange water or to stabilize the system through the farm. And what it meant, you had a typical farm, and maybe half the ponds were converted for water treatment, half or even 2/3 of the ponds. And you had a system where you recirculate the water. The idea was stabilize the system, control the waste nutrients, and have stable bacteria population into the rearing pond. And that meant moving from the traditional system, you treat your water, you bring the water in all the ponds, and then you flush out, that's it, to a new system where you recirculate the water through your farm, which is what has been done in, it requires investment. This is a problem, it can be costly, but this is one of the way of trying to cope. And what it meant was the old ways, you would treat the water, and typically you would stock your shrimp at that time. And with EMS, it meant the shrimp were hit immediately by the pathogen, and hence the mortality in the first few weeks. It's basically Russian roulette. You hope that you're not going to get the bad one to hit you. By moving to the other system, what we are trying to do is have control of the nutrients, so the our strategist bacteria, they grow very fast when there is nutrient. There's not enough nutrients for them. So these will stop to become dominant. Their numbers will go down. And those that are more adapted will start to grow and become more important. So this is how you can summarize the approach that was taken in the design of this new farming, where you would have still a beginning there, but very quickly you would have a system that is much more favorable to the shrimp, where you have much lower number of potentially pathogenic Vibrio. This is the approach that they used. Now, okay. What is interesting is that this approach can be used in many different systems. You can use it in hatchery, in nursery, or in farm. The concept can be applied to many different setups. It's not only for Asian or Latin America, or it's just a concept that can be applied. And this is information that I think will be available on the internet. This is a presentation that was given a few days ago in Thailand. It's called the TARS, yes, Aquaculture Roundtable. I think some of you here know about this roundtable meeting. And this colleague Manuel explained exactly the way the different protocols can be applied from nursery or farm, where you control water exchange, you have a stable system, you control your ammonia, nitrite, and your Vibrio. And it's a system that is actually much more cost effective once you accept to change your traditional way of farming. These are mostly data that he obtained in Vietnam that he was showing. But these should be available on the Roundtable website, I think, soon. Now, the next point is improve probiotics. Maybe the perception is, okay, it's another blah blah, it's fake story. But I would like to explain to you how you can improve probiotics. The classic first point, the only way you can work probiotics if you have a trust on the product. And the trust does not come from a salesman from the company, it has to come from third party. So, for example, when you have bacteria, you must work with a bacteria that is defined, clear, reported. You know which one it is. It's coming from a culture collection, is defined. The production must have HACCP, GMP, whatever, all the certification of goods manufacturing. So you know that what you buy today is the same as what you're going to buy in 1 month. And of course, all the quality control. There are many tools that allow you to prove the product is safe by third-party lab, SGS or any others. So this is the first thing. Second, how can we improve? This is a sentence, I think, that summarizes how we can do. And I will highlight each of the key points, try to explain to you how we try to improve the product. The first one, of course, is effective. Now, we know there's enough scientific papers or presentation to explain how typically companies do to develop probiotics or universities. The main point, of course, they have to be alive and active in your farm. There's no point bringing something that was designed for fermenting yogurt or sausages to put it into your farm. It should be designed for this. You can test the growth rate of this bacteria. As was presented earlier by Dariano about the multiplication time. Vibrio are very fast. But you can select probiotics that may not be as fast as Vibrio, but yet quite fast. So they will react faster to a Vibrio challenge. The main point, of course, waste control. That means you analyze the production of enzymes of all the strains and control the pathogen. Whether you use this technique or you use the antibiogram or others, but these are simple things that allow anybody to check the activity of a probiotics. Now, there are other things we can do. When we want to look at waste, what we want is to understand how the product works. And you can look here at the chemical reaction that occur when you have from aerobic, anaerobic, and so on. You have the typical set of chemical reaction that take place. How do bacteria interact with that? Actually, we are working now with another microbial ecology lab in Ghent University, where in that system here, you have this little vial, and you put sediment from a pond. You put your bacteria in there at the dose, and after that, you analyze the production of gas throughout. So it allows you to understand which reaction is taking place and the timing. And by doing it, we can look at all different strains of bacillus compared to a control and see which one is acting more on phosphorus, on carbon, or any cycle. By doing it, you can either select new bacteria or decide which one you want to increase in your product. So it's the same bacteria, but you increase the number of one versus the other according to the application. Safety, I think, is very important, safe for the shrimp, but also for humans. So we work with bacillus, so in our case, you can look at the overall safety of bacillus, but there are enough kits, PCR techniques to validate the safety to humans of whatever bacteria you choose. This is a big advantage of Bacillus, but lactic bacteria also. There are many kits that are available to validate. So when you do that, we mention what is effective and safe. This is really work in the lab. The next step, it's more in the factory, and this is a production of product with high number of bacteria. Because I want to explain again that when you buy probiotics, you don't buy powder or a kilo, you buy bacteria. And the exercise for anybody comparing any product in the market is based on looking at the price per kilo, but then see what is the price per bacteria and what is the amount of bacteria you put in your pond every time you apply. This is the only way a producer can make a cost-benefit analysis of the product, whether it's efficient or not. It's not looking at $15 or $60 per kilo of product, but it's to see how many bacteria you put for the price and what it means, and how many bacteria you apply in your pond every time. This is the only way you can analyze the cost effectiveness of a probiotics. The next step is how we can produce, as a company, the bacteria we select. So to explain to you how it works, the first step, it's here. You select the bacteria you like. So we have, each of the companies have their own strain that we believe in. This is here. Then you have a different step of production. Later on here, you harvest, centrifuge, rinse, spray dry. And at the end, you have dry powder of your pure strains. Looking at Bacillus, it means you start from these, growing one, and at the end of the production, they start to make spores, resting stage, and what we sell, what we obtain here are the pure spores, nothing else. And we do this for each bacteria separately, not together, one by one, because the medium is different for each bacteria. You need to give it the best for each strain. And then we have this. And of course, what you do after, you take the different one and you make other things. And this is how you end up with a commercial product. This is not the commercial product. This is just an ingredient. And then you formulate your product. Now, it seems simple, but actually, you can find a lot of research papers on how we can improve this. I showed you before, a product has to be cost-effective, cheapest price per bacteria. That means, as a company, to do that, we must make sure we can produce the highest number of spores for the lowest cost. Otherwise, we have to charge you more. So the way to be effective, we have to work on that. And there are many information you can search on the internet, publication explaining how you can optimize this. For example, which nitrogen you use, or how much calcium you put in your fermenter. And based on that, you can see how many spores are produced at the end of the cycle. So all the work there is no more on selecting a bacteria, but how to produce it in an efficient way. And by doing it at the end, we end up with the cheapest bacteria, normally, but we want to make sure they keep the activity. Because what's the point of producing a lot of the bacteria if they lose the activity? So this is where we need to make a balance between producing a lot of bacteria and make sure they are still doing their job. Why is it important? Because I just put 3 papers here, but you can find many, to show you the different production factors for lactic bacteria, Bacillus, that will impact the ability of the bacteria to still be good. For example, you may produce them, but at the same time, they will produce less enzyme. They will have been affected by the production. So we need to balance this. Now, you saw some presentation earlier about how you can control by feed probiotics or water probiotics with the Vibrio. And I will just finish by a few slides on that to show it to you. But in this case here, we looked at whether or not we can displace the Vibrio. At this point, all we could document was when you have a typical shrimp gut with a lot of Vibrio present, yellow or green colonies. If you apply probiotics at high dose, in this case here, we put about 10 to the 7th bacteria per gram. This is about the dosage. You can remove completely almost the Vibrio. Still a few remaining. When you stop, of course, the Vibrio is natural, so it comes back in. It does not mean here that the Vibrio is virulent or pathogenic. It just means you bring the Vibrio in the gut. With EMS, potentially, this is where you have a problem. So we knew that by coating probiotics on feed, either the farm or the feed mill, we can find a way of displacing the Vibrio. For example, in India or in Thailand, this is how they can control traditional white feces. You put probiotics in the feed and you clean up the gut. So it's sort of working. Now, the next step was, how does it work with EMS? And for this, we work in with a few research teams. This is the one in Vietnam, in Can Tho, and it shows you the survival of shrimp. If you don't challenge them, okay, they're okay. If you challenge them, you kill 70% of the shrimp. And if you put antibiotics, even if we are not recommending it, we always include antibiotics as a reference, you of course have a better performance, because in this case, that bacteria is not resistant to antibiotic. And then what we do is see what happens when we put probiotics in the feed or in the water. Because according to the system, if you put in the water or in the feed, in a closed system, you're still gonna colonize the gut with the probiotics. And what we can see is that if you put bacteria that can be alive, active, you know they can displace the Vibrio, well, obviously, you will not have so much EMS problem, because to have the HPND, you must have the Vibrio to colonize the gut. So it was one nice way to show how you colonize the gut, therefore you should not have Vibrio problem with EMS, and how it's confirmed in the lab. And the same, this is a separate study of what was shown earlier, where we looked also at the benefits in different systems, clear water or biofloc, and how even if biofloc system is definitely by itself improving the survival of shrimp, combining it with probiotics will give you an even better performance. So you have always to consider this. And I would finish to just show you that you're working with the same bacteria that we've been working on from the beginning, but how we look at improving the product with these bacteria by just improving the performance of the same bacteria or improving the quality of the production of the pure strain, you can end up with an improved product, which is on the label exactly the same, because all you do is improve it's like you train your bacillus to be more efficient. It's the same bacillus, but you train it, you prepare it to be stronger. And this is work we did in our R&D center in Thailand. And it showed how the improved formulation, the improved product, can lead to better growth or survival just by making the bacteria more efficient when you use them as feed or water application, in this case feed. Now, if we look in the conclusion, the need to control Vibrio now, if we look at disease before, the focus was mostly Vibrio for hatchery, but in the farm, it was basically viral disease. Vibrio were forgotten. The last 5-7 years have changed everything. So now there's a real focus again on bacteria. What is nice is now we see more and more an agreement that we need to understand microbiology, how it works. Not only shooting with antibiotics, but managing the system. And it means work with well-defined products, well understood, registered. I insist on registration. If it's a clear, well-defined process, this is the best. Then you are sure that what you get has been checked by authorities, by third party. You can trust the product. But the design of farming, I think there were discussions also yesterday how we need to look at adapting the production to the conditions, not stay the old ways, but progress. And how you can combine the new design of a farm with the use of quality product to really give you the best outcome. And finally, that the product like probiotics can help you all the way to your cycle. They are not magic, but you can analyze why they could help you for a certain situation. And they're just part of an overall protocol that any farm would have. Thank you very much.